Hi friends, welcome back to our channel. This is Kishore Parvalsa. Today we are going to discussing about power factor meter. So here the cosine angle between voltage and current which is given as power factor. Okay, so here the power factor can be measured with the help of power factor meter. The basic difference between dynamometer type wattmeter as well as power factor meter, only difference is cos phi, nothing but power factor only. In case of ordinary dynamometer type wattmeter, with the help of that only we can measure the power only, that is given as P is equal to V into I. Okay, here we can calculate both voltage as well as current with the help of dynamometer type wattmeter. But if you want to go for power factor meter, directly we can measure the power factor without calculating both voltage as well as current to find the power. So from that power we can calculate the power factor. Those calculations which is existing in dynamometer type wattmeter but not occurring in case of power factor meter. We can directly measure the angle of power factor, that is given as cos phi in case of with the help of power factor meter. So that is the difference between ordinary dynamometer type wattmeter as well as power factor meter. So coming for the construction point of view, total construction which is very similar to the ordinary dynamometer type wattmeter as well as power factor meter, only the angle of placing of pointer, that is the only difference in case of power factor meter when compared to ordinary dynamometer type wattmeter. Here the consumer as well as the power management system trying to always maintain as a unity power factor in case of transmission lines, but that is the not possible in practically. Okay, if suppose let us consider transmission lines, the transmission lines which contains like inductance parameters and capacitive parameters like that. So here we are giving input supply, that is given as source voltage Vs. Okay, here this is the input and here we are getting output. So when compared to sending end voltage, that is given as Vs, the receiving end voltage always which is getting to the higher. So that is the basic expectations of a consumer requirement, but that is the not possible to in all conditions. So here we are giving some input supply voltage, that is Vs are like V. Okay, so at that condition some current will be flowing throughout the entire transmission lines, that is given as high here. So the product of voltage and current which is given as power, so that is given as input power here. So whenever the power flowing through the entire transmission lines, so ultimately some losses will be existing. So due to property of some inductors, so that's why when compared to sending end voltage, the receiving end power must should be contains some losses existing. So that's why always does not maintain to the unity power in case of transmission system. Okay, so in case of transmission system, from the receiving end side, the always changing of load gradually from time to time or else like a day to day. So from that instant the power factor angle also continuously changing. In that ordinary dynamometer type wattmeter we can calculate individual supply voltage as well as current flowing. So from that we can find the power. So from that power we can calculate the cos pi is equal to P by Vi. Okay, so this is the very complex process. Every time we are calculating power factor in the transmission line by the changing of load gradually. So if suppose instead of dynamometer type wattmeter, if we want to place power factor meter, we can directly measure the power factor time to time even instead of changing of load gradually. Okay, so that is the main importance of using of power factor in case of transmission system. But in case of ordinary dynamometer type wattmeter, we can't possible to quickly find the angle of power factor. It will be taken off more time. So that is the drawback of ordinary dynamometer type wattmeter compared to power factor meter. Okay, so this is the regarding of power factor meter importance in case of transmission lines. Okay, so if you have any doubt regarding this topic, please put on the comment section. I will give you a reply. Okay, thank you.